Come on, be honest. You expected a beautiful soft female voice with an Australian accent. Instead, you're getting mine. I apologize for that, really. But you won't regret clicking this video. We'll do awesome stuff here. We'll do an in-depth analysis of the largest cryptocurrencies and predict their future returns. The video is divided into two parts. First, I'm presenting the results of the analysis, and then I'm doing a code walkthrough for those who are interested in coding stuff like that. Very important, if you like the video, don't forget to subscribe to the channel. I thank you very much in advance, and I wish you a lot of fun watching the video. What we are seeing here are the price charts of the largest cryptocurrencies over the last 4 years. Excluded are stablecoins and forks, so we end up with Bitcoin, Ethereum, Litecoin, and Ripple. Remarkable is the rally in 2017, ending up at an all-time high for every cryptocurrency in the beginning of 2018. After that, the crypto bubble was bursting and every cryptocurrency was decreasing in value. Interestingly, the Bitcoin price was recovering in the beginning of 2019 until the mid of 2019. We are observing the same pattern for Ethereum, but not at the same level as for Bitcoin. So Bitcoin was recovering until I think that's roughly 60% of the all-time high. That is not true for Ethereum. We are also observing this pattern for Litecoin here, but we are not observing that for the Ripple. So the Ripple didn't recover at all. When taking a look at the most recent data, we are noticing that the Bitcoin price is not yet on the level as it was after the last recovery phase. That is not true for the Ethereum price, as this price is higher than after the last recovery phase. I think that's a pretty interesting observation. As you probably know, or you are seeing that on the y-axis as well, we are working with different scales. Or in easier words, Bitcoin is worth more Ethereum, Ethereum is worth more Litecoin, and Litecoin is worth more Ripple. So the problem with that is that we can't really compare those charts here. So we need relative changes, and that is done on the next slide, where we are taking a look at cumulative returns. So what I'm doing here is taking the daily relative price changes or percentage changes and cumulating them over time. And what we're noticing now is that the Ripple actually outperformed every other cryptocurrency, followed by Ethereum, then Litecoin, and then Bitcoin. That's actually a pretty interesting observation. So you need cumulative returns to make different scaled assets comparable. Let's move on to the next slide, and that is showing the volatilities of the cryptocurrencies or the daily fluctuations. Let's take an example to understand what's going on here. On this day, the Bitcoin was rising by roughly 25%. On this day, the Bitcoin was falling by roughly 35%. What we are seeing in general when taking a look at all diagrams is that the volatility trend is downward. So we're noticing less volatility with the time in the last 4 years. But I'm really cautious with that statement. That can change in days or in hours. But as we see it here, we are seeing a downward trend of the volatility. Also remarkable is this crash here for every single cryptocurrency. So we have a Bitcoin crash of, as said, roughly 35% on a single day, a crash of the Ethereum price, also Litecoin, and also Ripple here. What's also pretty interesting is that the volatility seems to be least for Bitcoin and most for Ripple. There's way more stuff you can observe here. For example, the volatility spikes and the reoccurrence of those volatility spikes. You can find patterns here. And what's very interesting is that in the most recent time here, we are seeing that we have a very low volatility, so it's time for another spike, right? Let us move on to the next slide. And that is actually the most interesting one, at least in my opinion. What we are seeing here is on the x-axis the returns. And we have positive returns on the right-hand side and negative returns on the left-hand side. On the y-axis, we are seeing the frequency or the number of occurrences. So as an example, the most frequent value for Bitcoin over the last 4 years, that's important, was a neutral return, so 0.00 or something around that. If we are comparing that to the other cryptocurrencies, we are noticing that the most frequent value for Ethereum was actually slightly positive, as we see here. For Ripple, we have a contrary result. So we have a slightly negative value as the most frequent value for Ripple. And for Litecoin, we have something around 0.00 as well. What is also pretty interesting is comparing the left-hand side with the right-hand side of the distribution. And what we are noticing here is that it seems to be that the left-hand side is larger than the right-hand side in general. That is true for every cryptocurrency, as it seems. I'm really cautious here. So comparing left-hand side again, right-hand side, we are noticing the larger left-hand side here. If we are taking a look at the tails of the distribution, and these are like those extreme values here, we are noticing that the tails for Bitcoin are the smallest, but the other tails are not really different from each other. Maybe the Ripple tails are the largest. And that's it for the return distribution. So let's get to the outlier analysis. I've used a box plot here on the left-hand side with outliers. And this is showing us that we have a huge number of outliers here. What we are also noticing is that we have very extreme outliers, such as a Ripple outlier of 180% on a single day. That's just insane. An 80% outlier as well for Ripple and a 60% outlier for Litecoin. The number of outliers is such high that the boxes are actually compressed, so we don't have insights here. That is why I'm using the right-hand side chart to exclude all those outliers to have insights in the boxes. And what we are noticing here is that the median, and that is the green line inside the box, for Bitcoin is slightly positive. The median for Ethereum is nearly zero, but slightly positive as well. The median for Ripple is slightly negative, and the Litecoin median seems to be at zero. The boxes are the interquartile ranges, so that is the 75 quartile minus the 25% quartile. And the interquartile range for Litecoin and Ethereum seems to be the highest, followed by Ripple, and then we have Bitcoin as the least interquartile range. Now let us take a look at how those cryptocurrencies are correlated. On the left-hand side, we have the correlation matrix of the four cryptocurrencies. On the right-hand side, we are just visualizing this correlation matrix. So this is not different from this one here. The very first row is containing the correlation between Bitcoin and every other of those cryptocurrencies. And what we are noticing here is that we have a pretty high correlation with Ethereum and Litecoin, but we have a pretty low correlation with Ripple. That's pretty interesting. So let's take a look at Ripple in general and its correlation coefficient with the other cryptocurrencies. And we're noticing that we have a low correlation with every other cryptocurrency. And I think that's a pretty interesting observation as well. Okay, now let's get to the interesting part, the prediction of cryptocurrency prices. I'm using the time series prediction model developed by Facebook's data science team, fbprophet. First of all, we have to backtest the model. So I'm going 1 year back from now on. So I'm starting in August 2019 and I'm feeding the model the data. And what I'm getting here, as you see, I'm getting the totally wrong prediction, as you see. So I'm ending at a Bitcoin price of roughly 25K. That's absolutely wrong, as the Bitcoin price of today is around 11,000 as far as I'm concerned. So I had to amend stuff here, and I'm just running the same model for just a 6-month time horizon. And that is the next slide. And as you see, we're getting a pretty accurate prediction here. So we are getting a Bitcoin price of 11,000. So this model has performed very well. Of course, this could be a lucky case, right? So don't think that this model can predict cryptocurrency prices, but at least that is a pretty nice prediction. So let's finally predict the future. And we are starting from today on. And let's see where the Bitcoin price is in 6 months from now on. And that is actually at roughly 8 or 9K. Okay, so in the beginning of 2021, the Bitcoin price should be at 8 or 9K according to this model. So let's see if this is right or wrong. Let us briefly take a look at the code of this whole analysis. We are starting with importing the necessary modules here. After that, we are getting the cryptocurrency prices from the internet. I already covered that in another video on my channel. I will link that in the right corner and in the video description, so I'm not getting much into detail here. We are going 4 years back from now on, so we are getting a data frame starting at 2016 and ending at today. So we got roughly 1.5k trading days or price data of all cryptocurrencies. After that, I'm plotting this data, and this chart is totally misleading as it does not take the different scales of the cryptocurrencies into account. So we have to get the relative price changes. Therefore, we are taking the PCT underscore change function out of pandas and apply it to the data frame df, which is just our data frame containing the price data. The drop NA function is just cleaning the data from non-numerical values. After that, we are getting the daily returns here. So these are just the relative price changes of every cryptocurrency. To get the price changes over time, we have to cumulate these returns. And that is what we are doing in the next step here. So we are just using the cumulative product function of pandas, first adding a 1 to the return, then using the function and then subtracting the 1 again. So this is just the formula for cumulating returns. So you can look that up. I'm not covering that in this tutorial. This is just the procedure of cumulating returns, no matter if that's stock returns or cryptocurrency returns or whatever returns you can imagine. What we are getting now is the data frame containing the cumulative returns, and we are ready to plot this data to compare the cryptocurrencies. And this is exactly what we are doing in the next step here. So we are using the plot function and apply that to this data frame, daily cumulative returns. And I've specified some individual colors here. You can keep the default colors as well, but I'm using some individual colors here as I think they are more beautiful. I'm also amending the figure size here because the chart which I'm getting from the default plotting is just too small. So I'm amending the size of this chart here. But this is nothing you have to do. This is just a beauty procedure as well. Also, I'm defining a title as this makes the chart more meaningful. Let's move on to the next chart, and that is the price charts over the last 4 years. And what I'm doing here is using subplots, and I'm defining 2 times 2, so that I'm getting 4 subplots here. To access those subplots, you have to use those arrays or lists here, which contain the numbers where this plot is at. So a 0, 0 is indicating that this plot is in the upper left corner. A 0, 1 is indicating that this plot is in the upper right corner, and so on. So 1, 0 is the lower left corner, and a 1, 1 is the lower right corner. What I'm also using is the figure size to make this chart a bit bigger here. And this argument grid spec is just the distance between those charts. So that is the width space, this one here, and that one is the height space. What I'm also doing is to define different colors for each chart here, and I'm setting a title for each subplot. And that's it for the price chart. So I think subplots are very useful, and they're a pretty nice tool to compare certain charts, no matter if you're using that for bitcoins or cryptocurrencies in general or for stock prices. They're actually a pretty nice tool in my opinion. But nevertheless, let's continue and move on to the next one, which was the volatility chart. As you see, I'm just using the exact same syntax again, but now I'm plotting daily returns here to capture the daily fluctuations. And I'm also setting a Y limit here to make the fluctuations or volatilities comparable. If I wouldn't do that, every cryptocurrency would have an individual level here, and we wouldn't be able to compare those volatilities. Let's move on to the histograms. As you see, we still got the same syntax here, so we're using subplots again. What's different now is we're using the hist function to create a histogram, and we're using the daily returns to create this histogram. And the bins are just the number of those bars which you are seeing here. So if you would decrease this number, you would get wider bars. So let's actually do that to see what is happening. As you see now, we're getting wider bars here and a less number of bars. I think 100 is a pretty good number to capture the daily returns, but it's like you can define it whatever you like. So this is of course more detailed, as you see here. So what I'm also doing is to set an X range, and that is again to make those cryptocurrencies comparable. If I wouldn't do that, this would be individual depending on the distribution for each cryptocurrency, and also would take extreme values into account and would like compress those charts. So imagine we got a 1 point something value here, then this chart would be like compressed in the left corner, and we wouldn't get such nice insights as before. So I think the X range of 20% minus and 20% plus is a pretty nice range to capture the effects of return distributions. Now let's take a look at the outlier analysis, and I've used a box plot for that. What we've already analyzed is that we have a high number of outliers in general for each cryptocurrency. We have those insane outliers for Ripple here, and for Litecoin here. The problem now is that we don't see what's inside those boxes, but this is actually pretty interesting to see. So to get rid of all those outliers which are compressing those boxes, I'm just ignoring them by setting the argument show flyers as false. So what we're getting here is the box plot without outliers, and that is actually pretty interesting. As we see, the median is only positive for Bitcoin, slightly positive for Ethereum, negative for Ripple, or slightly negative for Ripple, and kind of neutral for Litecoin. So it's zero, not neutral, of course. The highest interquartile range we have for Litecoin, and that is followed by Ethereum and afterwards by Ripple, and then we got the Bitcoin interquartile range, which is the smallest. Now let's move on to the correlation metrics of the cryptocurrencies. And as said in the analysis, this is just the visualization of this correlation matrix. And to create such a correlation matrix, you are just using the core function of the data frame, which is the daily return data frame in our case. And afterwards, we are visualizing that by using the Seaborn module, which we imported as SNS, using the heat map, and then take the correlation matrix as the argument. And what we're getting is this correlation matrix, what we already analyzed. Now let's get to the maybe most interesting part of this video, and that is the prediction model. For that, we're using the fbprophet module. This module was designed by the Facebook data science team and is used for predicting time series data. I already made a video on how to use this module on my channel, so I will link that in the right corner and in the video description, so I'm not going much into detail here. We are starting with importing the fbprophet module, and I also imported the warnings module to turn off the future warnings, which are just annoying for this presentation. Afterwards, we are defining the time horizon, and we need two time horizons here, one for the 1 year backtest, which is just going back 1 year, and one for the 6-month backtest, which is just going back 6 months. We also need a start date, of course. After that, we're doing the online requests, and I just did 2 online requests here for every time horizon. So this is DF1 is for the 1 year backtest, DF2 is for the 6-month backtest, and after that, we're actually defining our model and using our first data frame here, which is our 1 year backtest, defining the parameters of this model. Again, this is explained in detail in the other video. I'm not going much into detail here. And we are fitting this module to the first data frame. And we're doing the exact same thing for our 6-month backtest here. So we are defining the profit module again and using the DF2 parameters to fit the model DF2 to DF2 here. And after that, we are just defining our future time horizon. So this is what you're seeing here. So we are using the make future data frame function of the model and define 365 days for the 1 year backtest and 180 days for the 6-month backtest. After that, we are using the predict function and apply that to the future time horizons, which we defined here. So this is the 1 year backtest and this is the 6-month backtest. And after that, we are getting into plotting. So we are using the plot function of the model, and we are taking the forecast 1 as the argument and naming this graph. And as we already saw, we are getting a totally misleading prediction, right? So we have like $26,000 per Bitcoin, which we would have on the day of today, right? So this is a wrong prediction. After that, we are plotting the 6-month prediction, and what we have noticed is that this prediction has performed pretty well, right? So we are getting the exact Bitcoin price as of today. So this is a pretty nice time horizon to predict Bitcoin as it seems. So with that, we are using the time horizon to predict the Bitcoin price from now on. So the next step is to define a third model here, and that is model FB3. And this is the same way again, but I'm just using the very first data frame, which is containing the dates until today. So I'm not defining a new time horizon here, I'm just using the very first data frame df here, use the very same procedure as before, make a future data frame with 6-month time horizon, so 180 days here, predicting to this future time horizon, and I'm plotting this model again. And as you see, we are getting a Bitcoin price predicted of roughly $8,000 or $9,000 in the beginning of 2021. So let's see if that's right or wrong. What I also want to cover is a brief regression here. So I'm trying to explain the Bitcoin price with the other cryptocurrencies. And what I've done here is running a simple linear regression first with Ethereum, and then just adding up the cryptocurrencies which we analyze. And what's interesting here, or kind of interesting here, because this model is somehow bad, which you will notice in some seconds, what I was observing here is that when I'm adding a cryptocurrency to this model, I'm getting a higher R squared, and the R squared is just the goodness of fit of a regression model. So this is telling you if this regression model is actually good or bad. And what we are noticing is if we are just using Ethereum, and that is the very first R squared here, so this is just the Ethereum R squared, we are getting 0.39, so a pretty bad R squared. If we are adding Ripple to this regression model, we are getting just a slightly higher R squared, but if we're adding the Litecoin to this model, we're getting a distinctly higher R squared. So I think that's also pretty interesting, but as said, this is not a good model, but I just want to cover that in this analysis as well. And that's it. I thank you very much for watching. If you enjoyed the video, please consider subscribing to this channel and liking the video. Comment your questions or your thoughts on the analysis. I'm really interested in that. I'm looking forward to seeing the upcoming videos. See you next time. Bye bye.